Olá, minhas grandes, Tia Morgana aqui de volta para mais uma live. E eu não sei o que fazer. Então eu vou tentar fazer tutorial desse cara aqui. Eu já tentei fazer ele uma vez, falhei miseravelmente. Mas vamos ver o que sai. Tem 60 vídeos e alguma coisa deve sair. Muitos vídeos. Muitos vídeos. Não sei inglês. Espero que não dê direitos autorais. Igual o vídeo do programador que eu tava fazendo Pong dele. E é isso. Vamos tentar fazer.
We're going to be using the lightweight Java game library and the new OpenGL stuff, none of the fixed function pipeline stuff because a lot of that is now deprecated. So we'll be using the new programmable pipeline of OpenGL 3 and above. Before we get started, just a couple of things about this series. I do assume a fairly good level of Java knowledge. This isn't a Java tutorial, so I'm not
Que nome que ele dá pro projeto?
Java-related aspects of it. Apart from that, you don't
Qual o mesmo nome?
prior OpenGL experience. I'm going to be doing a complete code walkthrough, and I'll explain all of the important bits as I go along. With that in mind, if you have done a bit of OpenGL before, then the first couple of tutorials probably won't be.
Esses vídeos são de 12 anos atrás.
Setting up the display and such, so you may want to skip the first few episodes. Before you get started, you will need to have a new Java project set up with lightweight Java game.
São tão velhos quanto o Learning OpenGL.
And if you want to watch a tutorial on how to do that, you can click here, or you can click the link in the description to go to Oscar's tutorial on setting up the lightweight Java game library environment. He actually has his own lightweight Java game library tutorial series, but it does use the fixed function pipeline, which, as I mentioned, we're not going to be using. So, hopefully you have now got your Java project set up with the correct
Aqui no
libraries installed.
Discord, quem quiser participar da live.
So let's create our first package. This is going to be where the meat of the render engine goes. So let's call it the render engine. And in here we're going to create our first class. And the first thing we need when we're making a game is of course a display.
O nome do projeto dele é Game Engine.
It's all about managing the display, called the display manager. And we'll go ahead and create that. And in here there's three methods that we need to create. The first one is going to be to open the display at the beginning.
Eu vou chamar o nome do canal dele. Team Matrix. Vou dar esse nome. Vou fazer em Silknet, ele está fazendo em Java. Então algumas coisas vão ser diferentes. Tem coisa que nem adianta eu fazer igual dele, né? .NET no console.
First thing we need to do when we create a display is to determine the size of the display. And we set the size of the display by doing display.setDisplayMode. And this takes in a display mode. So let's go ahead and create a new display mode.
CC.
And the display mode needs to know the
Program.
and the height of the display that we want to create. So I'm going to declare these up at the top. A couple of ints.
Apaga isso aqui.
Width, which is going to be 1280 pixels. And I'm going to set the height of the display to 720.
Aqui, class.
And you can set these
Read static.
really, whatever suits you.
Void main.
Just put these into the display mode constructor, the width.
Yargis.
So once we've determined, we need to surround this with try catch.
Precisa de código inseguro. Ele não tem autocomplete aqui. Eu não sei o termo aqui. É alô alguma coisa. Se tivesse autocomplete aqui era mais fácil. Mas aí é só pegar daqui também. GitHub. Acho que já tá aberto aqui. Aqui, ó.
Once we've determined the width and the height of the display, we need to actually create the display, which is pretty simple. Display.create. We could use this one, but we want to set a few of the settings first. So we're going to use this one that takes in a pixel format and a context attributes. The pixel format, you can simply just use the no argument constructor there to create a new pixel format and import that. But the context attributes, we want to set a few things first. So we're going to set
No options.
here. So create yourself a new context attributes. And the constructor here actually takes
Static void.
OpenGL that we want to use. So we're going to put it
Unload.
2, because that's the version of OpenGL that we'll be using. And two more
Create
settings
static void. Size.
attributes dot with forward compatible, because we want it to be
Int.
so we'll set that to true. And the second
New
one
size.
we do attributes
Create
dot
static void.
profile core.
Update.
There it is.
Delta
And we'll set that to true as well. These are
time.
just a couple of settings. You don't need to worry too much. They're not overly important.
It's static void.
There you go.
Render.
The final thing we need to do is to tell OpenGL where in the
Delta
display
time.
we can render the game. And we want to choose the whole display. And we do that by
Static
using
void.
GL viewport.
Closing.
And this needs to know the bottom left of the display.
Já vamos fazer aqui a classe game.
So the bottom left is just going to be the very bottom of the display, 0, 0. And the top right
Namespace.
the width and the height of the display in pixels.
Public class.
Tells OpenGL to use the whole of the display
Aqui game.
render the game in. So now let's
E
go
void
to the
init.
display method, and this is really simple. It's just a call to the
Void
display.destroy
update.
method, and that will close the display.
E void
To
render.
the display, we have to do two things. First, we need to sync the
E
display.
void
Display.sync.
clear.
This synchronizes the game to run at a steady FPS, and we can set the FPS that we want the game to run at.
Aí aqui.
And I'm going to set it up here
Option size new.
as
800 por 600.
is 120.
Options title.
And
Ele deu um título ali?
into the display.sync method.
Game.
And then also we just need to do display.update.
Options. Visible.
Very simple.
False.
That's it for the display manager class. That's all we need to do with the display. So let's go and create
Private. Static.
done.
E window.
And we'll
Window.
call this package engine tester.
Igual no.
And in here we're going to create the class that's going to have the main
It's
game
static.
So I'll call this
GL GL.
and you want to make sure that it has the
Igual
right
no.
in there.
Public static. GL
So
GL.
on our game, the first thing we want to happen is for the display to
Get.
so
Private
this is,
set.
we've just written a method for that. That's display
Igual
display
no.
manager dot create
Private
display.
static game.
Open up the display.
Game.
Then we want to go into the
Igual no.
actual game loop, and this is where all of the objects are updated every frame. All the rendering happens. So we've got the game logic and
Window igual.
rendering, and of course every frame
Window create.
we update the display.
Options.
Display manager dot update.
Window load.
And
Mais
we
igual.
want to check
Load.
when to exit this loop. We want to exit
Window
the
size.
exit
Mais igual.
by clicking the
Size.
and we can check if that's happened by doing display.is.
Window
So this will
update.
until someone
Mais
clicks
igual.
cross.
Update.
And
Window
finally,
render.
when the
Mais igual.
exit,
Render.
close down the display by doing display manager
Window.
close display. And we can run that now, and that should
Closing.
There we go.
Mais igual.
Close up the display.
Closing.
And when we click the X, it will close that down. One other thing I can show you.
Try cat.
We can also set
Window.
the title of the display
Wrong.
by doing display.set title, and you can set this to whatever you want. I'm going to set it to
Agora que ele vai dar um título.
display. And that should work.
Vou chamar de game mesmo. Ok. Aqui se operational system is Windows. Windows Center. Window Visible tree. GL igual a window create OpenGL. GL. GL viewport 00 int newsize.x newsize.y. Fazer a pasta úteis, pasta math, a pasta inputs, vamos trazer aqui do Pong. Isso aí é pra quê, chefia? Não sei, vou tentar fazer esse tutorialzinho aqui que ele tá fazendo em Java, mas eu vou fazer em C#. Tentar fazer. Já tentei fazer esse tutorial uma vez e não deu muito certo. Na verdade, apaga tudo isso aqui. Pega assim mesmo. Aí tem que trocar aqui pra... Só trocar pra isso. Eu vou dar um jeito de sempre reutilizar isso aqui, porque eu sempre preciso disso.
So let's go ahead and run that, and there you go. So that's it for this tutorial. I know it was a bit basic, but I have to start.
Aqui, debug. Error. Eu gosto de pegar daqui. Abre. Olha eu criar janelas. Silknet. Mas eu message. Não sei. De screen initialize. Window. Input initialize. Window. Time. Date. Delta time. Input. New frame. Ah, é. Game igual a new game.
Alô?
Ai, que susto! Oi!
E aí, beleza?
Eu sempre dou um susto, beleza? E aí?
E aí? Queria te fazer uma pergunta.
Diga. Outra?
Tu sabe algum curso de Java pra mim, cara?
Não entendi.
Gratuito, pelo menos. Algum curso de Java gratuito pra mim.
Curso gratuito. Então, esse cara aqui que eu tô vendo, ele tá fazendo em Java, mas eu não... É que eu só mexo com C#.
Ah, deixa eu falar. Mas esse cara aí que tá fazendo, ele mexe com Java também.
Oi?
Esse cara que tá fazendo, ele mexe com Java também.
Ele mexe com Java.
Pode me mandar, por favor?
Mando. Eu vou tentar fazer esse tutorialzinho dele. Esse aqui é OpenGL, tá?
Beleza?
Mandar aqui pra você. Eu acho que o lobo metalúrgico, ele mexe com Java. Aqui no servidor.
Não conheço. Eu entrei recentemente.
Aham. Seja bem-vindo. Do close.
Somewhere. Next week it will get a bit more interesting, going into the rendering side of things using VBOs and VAOs. So do look out for that.
É bem difícil achar conteúdo às vezes,
I hope you enjoyed it.
ainda mais em português. Nossa, barreira linguística é o que mais pesa pra mim.
Hello everyone and welcome to this week's Lightweight Java Game Library 3D game tutorial. And this week we're going to be rendering a quad using vertex array objects and vertex buffer objects. Vertex array objects are the modern way of storing and rendering models in OpenGL. No more of the old display lists or any of the old immediate mode stuff. But what are vertex array objects? A vertex array object, or VAO as I'm going to call them, is an object in which you can store data about a 3D model. The VAO has a load of slots in which you can store data, and these slots are known as attribute lists. And I think that a VAO usually has around 16 attribute lists.
Bons estudos.
We're not going to need anything like that many anyway. But usually you store different sets of data into different attribute lists. So in one, you might store all the vertex positions. In another, you could store all the colors of all the vertices, or the normal vector at each vertex, or the texture coordinates at each vertex, or whatever you want really. It's up to you what data you store where. And these data sets are stored in the attribute lists as vertex buffer objects, or VBOs. So what's a VBO? This is very simple. A VBO is just data. You can see it as pretty much just an array of numbers. Very simple. And this data could be anything. It could be positions, colors, normals, or whatever. And each VBO can be put into a separate attribute list in the VAO. So that's how data is stored, but how do we access this data whenever we need it? Each VAO has a unique ID, so when the VAO is stored off in memory, we can access it at any time using its ID. But how exactly do we represent a 3D model as a load of data that we could store in a VAO? Well, every single 3D model that we're going to be dealing with is made out of a number of triangles, and each of these triangles has, of course, 3 vertices, 3 points in 3-dimensional space. So each vertex has a 3D coordinate, an x, y, and a z, and if we take the coordinates of each of the 3 vertices of the triangle, and then all of the coordinates from the other triangles in the model, we'll have a list of data that represents all the vertex positions of the model. And it's this source of data that we can put into the VBO and store into an attribute list of a VAO. And that's what we're going to be doing in this episode. We're going to be rendering the simplest of 3D models, a rectangle, which is made of just 2 triangles. And we're going to be taking the vertex positional data of those triangles, creating a VBO, storing the data into the VBO, creating a VAO, storing the VBO data into one of the attribute lists of the VAO, and then we'll use the ID of the VAO to tell OpenGL to render the VAO rectangle VAO to whenever we desire. Let's get coding. So let's continue from where we were last time. You should still have your display working nicely, and if you have, you can go ahead and create a new class called raw model, and this class is going to represent a 3D model stored in memory. And there's 2 things we need to know about a model once it's stored in memory. We need to know its ID of the VAO, and we need to know how many vertices are in that 3D model. And we're going to create a constructor here, which obviously takes in the ID of the VAO that the model is stored in, and also the count of the vertices, so how many vertices there are in that model. Just a simple constructor here. And we also need some get methods, so we're going to generate getters here.
Isso tá mais chato que eu lembrei. Do que eu lembrava.
And that's the raw model class done. So let's move on to the next class, and this class is going to deal with loading 3D models into memory by storing positional data about the model in a VAO. So I'll create a class called loader, and we're going to create a method that will take in positions of the model's vertices, load this data into a VAO, and then return information about the VAO as a raw model object. And there's 3 steps that we need to take to carry out this method. The first thing we need to do is to create a new empty VAO. And we're going to create a method here that's going to do that. And this method will return the ID of the VAO that we create. Then we're store the data into one of the attribute lists of the VAO. So we'll have a method for that which will take in the number of the attribute list in which we want to store the data and also the data itself. And the final thing that we need to do is to have a method that unbinds the VAO. When you've finished using a VAO, you have to unbind it, and I'll explain it a bit more later. So let's go back to this first method here, and let's lay out what we're going to do here. So the first thing we're going to do is to create that empty VAO and to get the ID of it, and we'll store the ID in a variable called VAO ID. Then we're going to store the positional data into one of the attribute lists of the VAO, and we're going to store it into the attribute list 0. No particular reason, but it is the first attribute list, so why not? And then, now that we've finished using the VAO, we will unbind it, and then return the data that we've created, the information about the VAO, as a raw model. So that's going to take in the VAO ID, and it also needs to know the number of vertices of the model. So that's going to be positions.length, and we're going to divide that by 3 because of course each vertex has 3 floats, an x, y, and a z. So let's start work on this first method here, the create VAO method. And those. So what's a VAO? It's a VAO that is called the VAO. Last time you should class it in memory. And this
Vamos tentar fazer do jeito dele, vai. Ó, model.
two things we need to know about a model once it's stored in memory. We need to know its ID of the VAO, and we need to know how many vertices are in that 3D model. And we're going to create a constructor here, which obviously takes in the ID of the VAO that the model is stored in, and also the count of the vertices, so how many vertices there are in that model. Just a simple constructor here. And we also need some get methods. So we're going to generate getters here. Just select getters and press OK. And that's the raw get methods. So we're going to generate getters here. Just select getters and press OK. And that's the raw model.
Ok.
Class done. So let's move on to the next class, and this class is going to deal with loading 3D models into memory by storing positional data about the model in a VAO.
Loader.
So I'll create a class called loader, and we're going to create a method that will take in positions of the model's vertices, load this data into a VAO, and then return information about the VAO as a raw model object. And there's 3 steps that we need to take to carry out this method. The first thing we need to do is to create a new empty VAO. And we're going to create a method here that's going to do that, and this method will return the ID of the VAO that we create. Then we're going to need to store the data into one of the attribute lists of the VAO. So we'll have a method for that which will take in the number of the attribute list in which we want to store the data, and also the data itself.
Story data.
And the final thing that we need to do is
Attribute list, meu Deus do céu.
the VAO. When you've finished using a VAO, you have to unbind it, and I'll explain it a bit more later.
Boot
So let's go
number.
back to this first method here. And
Boot
let's
data,
lay
meu
out what
Deus.
we're going to do here. So the first thing we're going to do is to create that empty VAO and to get the ID of it, and we'll store the ID in a variable called VAO ID. Then we're going to store the positional data into one of the attribute lists of the VAO, and we're going to store it into the attribute list 0. No particular reason, but it is the first attribute list, so why not? And then, now that we've finished using the VAO, we will unbind it, and then return the data that we've created, the information about the VAO, as a raw model. So that's going to take in the VAO ID, and it also needs to know the number of vertices of the model. So that's going to be positions.length, and we're going to divide that by 3, because of course each vertex has 3 floats, an x, y, and a z.
Dividido por 3.
So let's start work on this first method here, the create VAO method.
Você está criando o quê? Tentando fazer um tutorial de OpenGL. Ativar o ID igual a... Ixi, tá usando GL30. Create GL, Program GL, Vertex Array, tem que ser int.
We then need to activate this VAO. If we want to do anything to it, we have to activate it by binding it. So we call GL bind vertex array.
GL bind vertex array val ID, até aqui dá para fazer.
We put the ID of the VAO that we want to bind, and we're going to return
val ID
from this method. And the vertex
coloca tudo int aqui. Oh shit. Int.
Vertex array object will stay bound until we unbind it, which is what we're going to do in this method here. And we can do that by calling that same method GL bind vertex array.
Bind vertex array 0.
ID in here we just put 0, and that will unbind the currently bound VAO. So let's move on to storing data into one of the attribute lists. Firstly, as I said earlier, we have to store the data into the attribute lists as a VBO. So let's create ourselves an empty VBO by calling GL buffers, and that will return the ID of the VBO that we've created.
Bind
now,
buffer.
we need to bind the buffer, because, as I said, same with the VAOs. If you want to do something to a VBO, you have to bind it first. And here we have to specify the type of VBO, and it's going to be a GL array buffer. And then we
GL15.
the VBO that we want to bind. So now that it's bound, we can store data into it. And data has to be stored into a VBO as a float buffer. So I'm going to create a method down here that's going to
Float
convert
buffer não
the
existe.
of data into a float buffer. So
O que seria equivalente a float buffer? Que seria equivalente do Java float buffer para C#. Span float. Ixi, ele.
let's just call this store data in float buffer, and it will take in the float array that we want to convert to a float buffer. And the first thing we have to do is to create ourselves an empty float buffer, simply by calling bufferutils.create float buffer, and it needs the size of the data, which is pretty simple.
E aí já começa onde não dá pra fazer.
And so let's go ahead and import this. Then we're going to put the data into the float buffer, which is as simple as it possibly could be. Buffer.put data. Then we need to prepare the buffer to be read from, because at the moment it's expecting to be written to, but if we do buffer.flip, it knows that we've finished writing to it and it's preparing to be read from, and then we'll return that buffer so that we can use it.
Usa para C Sharp, Silknet. Random spam. O próprio array em C Sharp funciona como um buffer contínuo na memória.
To store into the VBO. So let's go ahead and call that method now and convert our data into a float buffer. So once we've got a float buffer with our data in it, we can store it into the VBO. So let's go ahead and do that. And we do that by calling GL buffer data. First of all, we have to again specify the type of VBO, which again is a GL array buffer. Then we put
Que só seria assim.
and then we need to go ahead and
Fixed
specify
float.
what the data is going to be used for, whether it's static data or whether we're going to edit it once we've stored it. And we're not going to edit it ever again. So
Data? Tá.
So that OpenGL knows that we never want to
GL
edit the data once it's stored.
for data array buffer.
And now we're going to go ahead and put that VBO into the VAO, into one of the attribute lists. And we do this by calling GL vertex attrib pointer. And this takes in a whole load of arguments, which I'll explain now. So the first attribute, the first argument that it takes in is the number of the attribute list in which you want to store the data, and that's just going to be attribute number. Then it wants to know the length of each vertex, which is 3 because they're 3D vectors, an x, y,
the size of float.
Then it needs to know the type of data,
Buffer.
it's just a float. Then it needs to know if your data is normalized, and ours isn't, so we
Agora ele não usa isso aqui.
Then it needs to know
Não
the
tem como.
distance between each of your vertices. Have you got any other data between them? And we haven't, so 0. And finally, the offset should start at the beginning of the data. Yes, it should, so
GL enable 0.
And then finally, because we've finished using
GL
VBO, we can unbind
vertex pointer 0.
as with the VAO, we just call the bind buffer.
3.
To specify the type of VBO, which once again
Float false.
buffer. And then instead of putting an ID
3 vezes
0, which will unbind the current VBO.
size of float.
That's how you store data into a VAO. There's one more thing we have to do in
Vai de
this,
0.
a bit of memory management.
Volta.
The current VBO.
Aí aqui GL bind buffer, read buffer 0.
So that's it. That's how you store data into a VBO.
Pera aí.
In here we just put 0, which will unbind the current
Attribute number. É isso aqui. Mas aí tem que ser o int.
VBO. So that's it. That's how you store data into a VAO. There's one more thing we have to do in this class.
Certo.
It's a bit of memory management. At the end, when we close down the game, we're going to want to delete all the VAOs and the VBOs that we've created in memory. So I'm just going to declare a couple of lists at the top here, and they're going to keep track of all the VAOs and VBOs that we create.
Let's list
So just import
VBOs.
these. And then we're going to go into the code here, and whenever we create a VAO, we're going to add it to the VAO list so that we can delete them later.
Voz,
And the
pode,
same with the VBOs. As soon as a
void,
VBO is created, we will store its ID in the VBO list. And then
VBOs,
when we close
pode,
down the game, we want to call a
void.
method that will delete the VBO list. And then when we close down the game, we want to call a method that will delete all of the VAOs and VBOs in these lists. So let's create a method called cleanup.
Cleanup.
And this is just going to loop through both of these lists and delete all of the buffers and VAOs in them. So first, for every VAO
For
in
isso,
the VAO list, we want to delete it. So we can do that by calling
val,
delete vertex arrays and put the ID of the VAO in
vals,
there. And pretty much exactly the same for the VBOs, except this time we call
gl delete,
gl delete
vertex
buffers,
arrays,
and we put the ID
val,
of the VBO in there. And that's
ref,
it. That's the loader class pretty much done.
Mentira. Não entendi.
Buffers.
Ref. Ok. For isso, int VBO, VBOs, delete buffers, VBO.
And we put the ID.
Quase perdi a vontade de programar. Quanta coisa. A primeira DS vendo essas atrocidades. O que é DS?
Of the VBO in there. And that's it. That's the loader class pretty much done. So now that we're able to load a model into a VAO, we need to create a class that can render the model from the VAO. So let's create a class.
Renderer. Namespace. Wiki class.
Class called renderer, and the first method that we need to put in here is
Quanta
a
coisa.
method called prepare. And we're going to
Não
call
viu
this once
nada.
every frame, and it will just prepare OpenGL to render the game.
Porque
What we
void
need to do at the moment
prepare.
with this method is to clear the color from the last frame, and we can do this by doing
VGL,
clear color, and then we choose
Log
the
and
color
gel.
of the backgrounds that we want, with one being the
Gel
maximum
clear
RGBs
color.
for the RGB values. So I've gone for a red background there. Then we need to
Zero.
actually make the method that will render a raw model, and this method will take in the raw
Void
model that we
render.
want to render. And this isn't too tricky, it's a lot easier than loading up into a VAO. First thing we need
How
to do is
model.
we need to bind
Model.
the VAO that we want to use. As I've said, if you ever want to do
Gel
something to a VAO, you have to
bind
bind it, and we have to put in the
vertex
ID
array.
of the VAO that we want to bind, and that of course we've got in the model.
Gets
We then
void.
need to activate the attribute list in which our data is stored. So we enable the vertex attribute array, and if you remember, we put our
Zero.
data in the attribute list 0. So that's the attribute list that we're enabling. And then we're going to go ahead and render it.
Ah, ele não chama isso aqui. Jelly draw arrays.
And we're going to use the method glDrawArrays. First, it needs to know
Type
what we
triangle.
want to render. We want to render triangles. So let's put glTriangles here. Then it wants to know where in the data it should start rendering from, and we want it to start at the beginning. And it also needs to know how many vertices it should render, which we have that number in the model.
Vertex counts.
And then we've finished using everything, so we need to disable that attribute list, that zero attribute list. And we also need to unbind VAO, which we know how to do now. It's just gl bind vertex array, and instead of putting
array
ID
zero.
here, we put 0. And that's the rendering class done. So let's quickly go to the main loop and very quickly put all this together and see if we can render a quad. So let's create a loader object so that we can use the methods from the loader class. And let's do the same with the renderer so we can use all those
Loader, new loader, renderer, new renderer.
methods that we just created, and import both of those. And we also have to remember to clean up the loader once the game has closed, to delete all the VB.
Então eu vou botar isso aqui fora. Create loader. Create renderer. Loader igual new loader. Renderer igual new renderer. Loader cleanup.
VOs and VAOs that we've created. Also, as I mentioned, we have to prepare the renderer every single frame, so let's call that method. And now what we need is the list of vertices for the quad that we want.
Faltou clear color, né? Será que ele vai chamar ainda?
To render, and I've actually got them copied here, so you can just copy them this week.
Private float vertices uh, 0.5 0.5 0 1 2 3 1 2 3
I'll explain more about how I got those vertices next week, but for now just copy them. And we're going to load that up into a raw model using that load to VAO.
Aí reach how model igual a load total vertex
method that we had that we created earlier. And now that we've got that raw model, we can render it using the method in the renderer, which is render. And we put the model in there as the argument. And we can run that now, and there you go. We've put the model in there as the argument.
Model.
And we can run that now, and there you go. We've got a quad rendered onto the screen. So that's it for this week, renderer. Which is...
Se a gente vai ter quadrado branco? Acho que não, hein? Não.
Is render, and we put the model in there as the argument. And we can run that now, and there you go. We've got a quad rendered onto the screen. So that's it for this week. Next week we're going to be looking
Pixel de erro, minuto 13.
at the
Ah, tá. Mas eu não tô renderizando nem o quadrado. Gera clear. Color buffer bit. Mas e o quadrado? Load to val. Ah, não, tem um shader. Só tem um shader. A versão que ele usa não precisa de shader. Certo. E agora eu faço meu próprio shader ou eu uso o shader dele? Ô, Brian, quem você não?
being the maximum for each of these for the RGB values. So I've gone for a red background.
Shader. Aí. Has. Shaders. Shader. Vertex. Gera SL. Fragment. Gera SL. Pega aqui. Aqui. Ok. Shader. Aqui class. Shader. Pega daqui. OpenGL, debug, matemática. Private shader, shader, shader igual a new shader, has, shaders, shader, vertex, GLSL, fragment, shader use. Beleza.
Hello everyone and welcome to this week's lightweight Java game library 3D game
Depois
tutorial.
tenta usar
This week we're going to be
IntelliJ.
using the OpenGL coordinate system
Ideia
and learning about a
muito
more
boa.
efficient way to render models. But before we get started on that, there's one
Ideia,
technical last thing
mano,
that
é
I need
muito
to
boa.
correct. If you go
Ok.
into your renderer class, you need to add one more line in the prepare method.
Eu gosto do VS Code.
I managed to forget it
Pra
last
C
time,
Sharp
so let's
é
add
bom.
it in now. And this just
IntelliJ
clearly
é bom pra
comes
Java.
from the
Eu não tô
previous frame.
trabalhando em
So
Java,
go
eu tô
ahead and
trabalhando
run
em C
that to
Sharp.
check that it's working, and there you go. So last time we rendered a quad, but I didn't explain how to get these vertices here. So let's delete them and
Ele colocou clear color antes? Meu Deus. Ok.
so go ahead and run that to check that it's working, and there you go. So last time we rendered a quad, but I didn't explain how to get these vertices here. So let's delete them and I'll talk you through how I got them now. So first we need to look at the OpenGL coordinate system, and you can see it here. There's the X and Y axis with the origin in the center of the screen, 1Y at the top edge and -1Y at the bottom, and 1x on the right edge and minus 1x on the left edge of the screen. And finally, because we're working in 3D, the z-axis is pointing out of the screen towards you. It's quite hard to draw it here, but just imagine it coming straight out of the screen. So here's the quad that we want to draw. Hopefully you can see why the vertices have the coordinates that they do. So what order do we have to give these coordinates to OpenGL? If you remember from last time, everything we draw has to be in triangles. So we need to tell OpenGL about these two triangles here. And OpenGL always needs us to specify these vertices in a counterclockwise order. So let's start with the top left triangle here, and we'll start with vertex V0. No particular reason for choosing V0 first. I could have chosen any vertex, it makes no difference. But now I must go counterclockwise around the triangle to specify the other vertices. So the next one is V1, and then finally V3. And that's the top left triangle. So let's put those vertices in here now and run the game, and there you go. The quad is rendering just like it should. But there's and then here for tell index in. So let's count that in a different way. Well,
Como fez errado isso?
to total more coloring method and a method 100 using the first model. Let's now go ahead and add all of that into the code. So we'll start off in the loader class, and we're going to add a method here that's going to load up that indices buffer that I've been talking about and bind it to a VAO that we want to render. So this method will take in the array of the indices that we want to load up into the indices VBO, and it starts off just like any other VBO. We need to create an empty VBO by calling gl gen buffers, and that's going to return the ID of the empty VBO. And we're going to add that to the list of VBOs that we made last time so that it gets deleted when we close the game. Now we need to go ahead and bind the buffer because we want to use it. So gl bind buffer, that will bind the VBO. Now we need to specify the type of VBO, and this is different from last time because this isn't data, this is an element array buffer. And that tells OpenGL to use it as the indices buffer. And then we put the ID of the VBO that we want to bind. Now we want to store our indices into this VBO, and just like other data had to be stored into a float buffer first, the indices have to be stored into an int buffer. So let's create a quick method here to convert our int array of indices into an int buffer that we can store into the VBO. So this is pretty similar to the float buffer method. First we'll create an empty int buffer by calling bufferutils.createIntBuffer, and that needs to know the size of the data. Then we just put our data into the int buffer, and like last time we have to flip the buffer so that it's ready to be read from. And finally we just go ahead and return that int buffer. And now we can go back into here and we can use that method to convert our array of indices, our int array, into an int buffer. And then we'll be able to store that int buffer into the VBO. So let's go ahead and store it into the VBO now. And we can do that same as last time by calling gl buffer data. Again, this needs to know first the type of VBO that we're using, which as I said is not just an array buffer, it is an element array buffer, so that OpenGL knows how to use it. Put the data in there, and then finally, like last time, it needs to know how it's going to be used, how the data is going to be used, and it's just going to be used to draw static. We're never going to edit the data, so OpenGL knows that it doesn't have to worry about the data ever being changed. So one final thing that we need to do, because that's all for that method, that will bind the indices VBO to the VAO that we've just created in this method here. So we need to take in the indices VBO, and just after we've created the VAO, we're going to bind indices buffer to it by calling that method that we just created, bind indices buffer. And finally, the raw model needed to know the number of vertices, and that's now going to be the length of the indices buffer, which will still be 6. In the case of the quad. So let's go to the renderer. There's one change we have to make here. We're going to use a different method to render now that we're using the indices VBO to do the rendering. And this method is called GLDrawElements. And first of all, it needs to know the mode. What is it rendering? Just like last time, it's rendering GL triangles. Then it needs to know the number of vertices to render, which is in the model. Then it needs to know the type of data that we're giving it, and this time, because we're giving it the indices buffer, that contains ints. So GL unsigned int. And then finally, it needs to know the offset. Where in the data should it start? We want it to start right at the beginning, render everything, so we put a 0 there. So the final thing that we need to do to get all of this to work is to actually specify the model data that we want to load up and render. As you know, we now need 2 sets of data to represent our quad. Firstly, we need a list of the data of the 4 vertices in the quad, which is just the 4 positions of the vertices. And then we need the list of ints that will tell OpenGL the order in which these vertices need to be connected. So put this data into your main class like this, and make sure that your load to VAO method now takes in both the vertex data and the index buffer data as well.
C Sharp, minha linguagem favorita. Aê! É nóis.
And then you can go ahead and run the game. And there you go. We still have a quad, but this time using a more efficient rendering method. And although this won't seem very important now, it will prove to be extremely important later on, and it will help our game to render that little bit faster, as well as ensuring that models don't take up too much space in memory. So that is it for this tutorial. Next time we're going to be adding some color. Hello everyone, and welcome to the first part of this week's lightweight Java game library 3D game tutorial 1, including some computer. Position by you have the simplified grammar graphics GLS, the work and really the output of the vertices that row 0 output to shape as the shaded seed in the code right out blue pixel and outputs and fragments for this to like program some shaded programs for ourselves on. Hello everyone, and welcome to the second again. I think you'll fit into the data and that is if you just go in, you have to do 0, 0, hour 3 from the demonstration. So our output is a 3D vector called color.
Versão 400.
And this is the method
Que versão é essa?
Every time a vertex is processed by this vertex shader. And now we have to tell OpenGL where to render this vertex on the screen. And we do this by setting GL position. And this is a 4D vector, so we have to convert our position, which is a 3D vector, into a 4D vector. So call the constructor for z, also just by z and the y, automatically x cut. It's just going to be, and that will create. So now let's go into the fragment shader. As I said, has the for the out impulse vector to make the. I just want to give a component just one.
Vou fazer isso não, cara.
Component just one. So I just want to give a component just one to be color out to be a vector to be to shader. So I just these and program food GPL position the vertex for each right out. Access that that make up the program. So let's first create a method that can load up shader source code files like the two that we've just type. I've actually got the source does is to open up the source code files, read in all the lines and connect them all together into one long string before creating a new vertex or fragment shader depending on the type we gave it, attaching the string of source code to it, compiling it, and then printing any errors that were found in the code.
New String Builder. Meu Deus.
And finally, it returns the ID of the newly created shader. If you don't really know how the code for this method works, it's really not a problem. Construct putting to create a program and then in the program constructor pretty much it's going to be an abstract method because when we create an implementation, have this method bind attributes, and that's going to one of the attributes constructor. We want to use program ID, the program in, and then we also need one to clean up both the shader from the program. So we'll do that once for the vertex shader and then again for the fragment shader.
Tá, quanto tempo na área, minha jovem? Tô desde o final de 2019. Fracassando miseravelmente.
The shaders. Delete the vertex shader. And of course, delete the fragment shader as well. And then finally, we have to delete the program itself by calling gl delete program and putting in the program ID. So that is the shader program class almost done. One last thing, we need a method to bind an attribute because it can't be done from outside this class because it needs to use the program ID. So this will take in the number of the attribute list in the VAO that we want to bind, and it will take in the variable name in the shader code that we want to bind that attribute to. Then this just takes in the program ID and then the index of that attribute and the name of the variable ID and then the index of
Bind attribute location.
that attribute and the name of the variable in the shader code.
Nossa, vou ter que adaptar muito código aqui.
So now let's go ahead and create an implementation of this for the shaders that we've just created. So we're going to call this static shader because we're going to be using this in the future to create all our static models. This will extend shader program, and then it will want you to create a constructor and that bind attributes method. We're not going to take in a vertex shader string. We're not going to take in the file name. We're going to declare them up here. And then just put in the file path of that vertex shader file that we created earlier, which is source/shaders/vertex shader.txt, and then do exactly the same for the fragment shader, but call it fragment shader, fragment file, and then fragment shader.txt. And then we can put these into the constructor for the shader program. And finally, we just have to do the bind attributes. And we're going to bind attribute 0 of the VAO because that's where we stored our position, our vertex positions, and we're going to connect it to the position variable, the position input in the vertex shader. So now we can go into our gain loop and we can create a new static shader so that we can use it when we're rendering. And just import that. As well as that, we've got to remember to clean it up once the game's been closed, which is just shader.cleanup. And And before we render, we want to use the program, we want to start it, and we'll stop it again once the rendering has finished. So shader.start before the rendering and shader.stop after the rendering. And that should now
What?
work. And there you go.
Peraí, o que ele fez aqui no shader dele?
Vertex we do what we can the additional invites for each and containing all the attributes and methods that every. And now we have structs one opponent with vier parentheses, and again we have rectangle, and that will create a different color.
Ok. Vamos tentar. Shader. Alt. F color. E VPOS. Color igual a V4 VPOS X mais meio 1 pós Y mais meio e 1. E aqui V4 F color F color
Surface of the
não. Ué. Aqui Y. Também não. Ué. Alt F4 e aqui in. In. Também não. Caramba. É no shader vertex. Onde tá errado? Float. Não entendi. Linha 10. O que tá errado aqui? Aqui. Detesto shader. Ah, beleza.
fragment shader.
Temos um resultado.
And you can play around with the settings a bit if you want to see what other colors you can get. So you could divide the output color of the fragment shader by 3.
Fragment shader.
And that would
Dividido por 3.
make all the colors a little darker. Or instead you could go into the vertex shader and you could change. Or instead you could go into the vertex shader and you could change the green component of the output color to 0 instead of 1, and that will give you some other colors. Color to 0 instead of 1, and that will give you some other colors. Yeah, just play around with it, see what you can get, and just make sure that you understand what's going on, really. So that is it for this week. Next week we're going to be texturing quad. Hello everyone and welcome to this week's lightweight Java game library 3D game tutorial, and this week we're going to be texturing our quad. So let's get right to it, and we're going to start off in the loader class where we're going to create a method that's going to load up a texture into OpenGL so that we can use it. And this method is going to take in the file name of the texture that we want to use, and it's going to load it up into memory and return the ID of that texture so we can access the texture and
load texture in the file name.
use it whenever we want. So we're going to use the Slick Utils texture loader here, and that's going to take in the type of texture that we want to load up, and this is always going to be PNG. All the textures that we're going to be using are going to be PNG images, and it also needs to take in a file input stream, and we have to give this the file path of our texture, and it's always going to be in the res folder. We're always going to store our textures into the res folder once we've created it, and they're always going to be .ping. So import a couple of these, and we're going to need to surround that in a try catch. Let's just get rid of these. So we've loaded up a texture now, and what we need to do now is to get the ID of that texture, and that's pretty simple. Just texture.get texture ID.
Ok. .NET add package std image sharp. E vamos ter que fazer. Oh, droga. Vou pegar aqui mesmo. Vou pegar aqui. Load texture. Pode ser daqui. Talvez algo assim. Image. Que file path. Path. Recebe has textures file name .png.
And then all we're going to do now is to return that ID from the method. Now, like we did with the VAOs and the VBOs, at the end of when we finish playing the game, when we close it down, we're going to delete all of the textures. So we need to keep track of them when they're created. So let's create a list of integers, which will be all the texture IDs, and I've called that textures. And whenever we create a new texture, we're going to store the ID of the texture into that list. And then in the cleanup method, when the game has closed, we're going to loop through that list of textures. And for each one, we're going to delete the texture using DL delete textures. And that will delete the texture from memory.
Delete texture.
So now let's create a new package, and this package is going to contain all the classes to do with textures. So now let's create a new package, and this package is going to contain all the classes to do with textures. so we'll just call this package textures, and let's create a new package, and this package is going to contain all the classes to do with textures, so we'll just call this package textures, and let's create a new class in this folder, in this package, and we're going to call this class model texture, and this is going to be the class that will represent a texture that we can
Model
use
texture.
to texture our models. So at the moment the model texture only to,
Nem sabia que ele tava separando as
and we're
coisas.
going to call this class model texture, and this is going to be the class that will represent a texture that we can use
Porque
to
class model
texture
texture.
our models. So at the moment the model texture only needs the texture ID. In the future we'll add a few more things to this class,
Thread.
but at the moment we're just going to be using
Model
a simple
texture.
texture. So all it needs is the ID of the texture,
Entendi.
and we're just going to add one
Text
element
ID.
here as well for that ID.
Equivalente. Get ID.
Great. Now we're going to create yet
Sorry.
another package,
Thread.
and this package is going to contain models. So let's move our raw model class into there. Just click and drag it into models. Click OK, and it should now be in there. And we're also going to create a new class which is going to represent a textured model, because the raw model only represents model data, and the model texture is just textured data. But we want to have a class that contains both a model and a texture, and this is what we're doing now with the textured model class. This contains a raw model and the model texture that we want to texture that raw model with. Again, just a simple class here, not much going on in here at the moment. Constructor will take in a raw model and a model texture, and just set both of these. And then we're also just going to have two get methods which we can generate. Just right click and then go to source, generate getters and setters, and select getters and click OK. So that's the textured model class done. So before we go any further, we need to actually have a texture that we can load up into our game. So go into your file explorer, go into your projects folder, and then we're going to create a new folder called res, and in here we're going to put all the textures that we are going to be using in our game. So I've got this simple image here called image. You can use whatever texture you want, but it does have to be a PNG file, and it also has to be square, where each side of the square is 2 to the n pixels long, where n is an integer value. So it can be any of these sizes. So once you've got your texture set up and into the res folder, we can go back into the code, and let's go into the main game loop where we're going to load up that texture. So let's create a new model texture.
Pera aí. Ah não, tira esse mouse do meio.
Let's go ahead and run that, and hopefully, fingers crossed, that will work. There we go. So we've got the text.
Ser fiel. 256. 256 por 256. Image. Salvar como. Aqui, C Sharp. Has texture. Image. Ser fiel ao tutorial.
So once you've got your texture set up and into the res folder, we can go back into the code and let's go into the main game loop where we're going to load up that texture. So let's create
Game.
a new model texture called texture, and the constructor of this has to take in the ID of the texture, which we can get by loading up the texture using that load texture method that we made earlier in the loader class. So put in the name.
Private model texture. Texture igual new model texture. Load texture image.
Of your texture file there. And now we're going to create a textured model object. And the constructor for this will take in the model, the raw model that we have from previous episodes, and it also now takes in the texture that we just created.
Texture model. Texture model. Go new. Texture model. New texture model. Model texture.
And we just have to import that. Now let's have a look in the renderer class, because at the moment our render method is only rendering raw models, and we want it to now be able to render textured models. So let's change it to take in a textured model, but it does still need access to the raw model inside this method.
Texture model.
So let's get the raw model out of the textured model. So
model.
still use it.
Model.
Finding the vertex array and other
Go
things.
texture model.
And if we go back into
Get
the game
model.
loop, we need to put the textured model into that render method. When we go back into the game loop, we need to put the textured model into that render method when we call it. And this all will still work, but it won't be using the texture. So just run that and it should all still look like last.
Calma. Texture model.
Will still work, but it won't be using the texture. So just run that and it should all still look like last time, which is great.
Devemos obter o mesmo resultado, porque a gente não mexeu no shader.
Great, but we want it to use the texture. To texture an object, we have to tell OpenGL how it should map the texture onto the object. So first we have and given each texture so let's now go back into the code and we can put in the texture coordinates that we were just
Private float texture chords. Zero, 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 zero. Zero, 0, 0, 1.
talking about. You might notice here that I've actually got v1 and v3 the other way around now, and that's because in the diagrams I'd got v1 and v3 the wrong way around from how we usually have them. So let's go into the load to VAO method, because we now want to also load up the texture coordinates into the VAO.
Multi texture cards.
So it would be great if we could use this store and attribute list method for the texture coordinates as well, but I was a bit silly last time and I hard-coded this 3 into the code here. This is when we load something up into one of the attributes, we have to tell it how big each coordinate is, and for the positions this is a 3D coordinate XYZ, but for the textures it needs to be just a 2D
Int coordinate size.
coordinate. So instead of hard coding that 3 in there, we're going to take it in as a parameter for that
Int.
method. So let's now put the 3 in there for the position.
3.
Because they're a 3D vector, x, y, z, and then we're going to store into attribute 1, we're going to store the 2D vector, or 2D.
1, 2. Então aqui tem que se aplicar aqui também. Que não funciona. Int.
Coordinates, which are texture coordinates. So we put in our texture coordinate data there, and we need to put in the texture coordinates when we call that method in the main game loop. So let's now go into the vertex shader, where we can now access those texture coordinates from the VAO. For each vertex. So we're going to have a new input now, which is a vec2, a 2D coordinates, which
Certo. A color. Que esse é um. É um, né? Ok. Vertex cord.
which is the
Ftex cord.
texture coordinates. And let's just delete all this color stuff because we're not going to use that. We can't actually use the texture coordinates in the vertex shader, so we're going to pass them straight to the fragment shader. So let's create an output,
Tira isso aqui.
which is
Ok.
also a vec2, and it's just going to be, we're just going to call it pass texture chords, and we're just going to set that to the input
Vertex cord.
so that the texture coordinates get linearly into
Aí aqui. Ftex cord. Ftex cord. Texture.
plated all over the quad, and then they can be used in the fragment shader. So let's get rid of that color input, and the fragment shader's input is now that vec2 called pass texture chords that got passed to it from the vertex shader, and the output is of course still the output color of the pixel that's currently being processed, but we now have a new variable, a new type of variable. It's a uniform, which I'll be explaining next week. Don't worry about it too much right now. But this is a sampler 2D, and we're going to call it texture sampler, and this basically represents the texture that we're going to be using. And now we're going to use a special GLSL method called
E já volto,
gesture.
gente. Voltei.
And this takes in the texture that we want to sample, and it takes in the coordinates for the point on the texture that we want to sample. And what this method does is it returns the color of the pixel on the texture at those coordinates that we give it. So that method will sample the texture that we gave it in the sampler 2D, and it will sample it at those texture coordinates that we gave it in past texture chords, and it will get the color of the pixel that it finds at those texture coordinates, and it will return it. And what we're going to do with that color is we're just going to output it to the pixel that's currently being processed. So we're almost done now, just a couple of things left to do. Firstly, we need to link up this input variable, the texture chords input, to the vertex shader. We need to connect it to attribute 1 of the VAO, and we do that in the static shader class using the bind attribute method, and we're going to bind attribute 1 to the variable called texture chords in the vertex shader. So that will give the vertex shader access to the texture coordinates in the VAO. And now that we're using the attribute array 1 in the VAO, we need to enable it before rendering in the render method, and we of course have to then disable it after we've finished rendering. So disable vertex attribute array 1, and everything is now done, except we haven't yet told OpenGL which texture we want to render onto our quad. So the way we do this is we have to put it into one of the texture banks that OpenGL provides us with. So we had to activate one of them. We're going to activate just the first texture bank, texture 0, because this is where the sampler 2D, remember the sampler 2D uniform in the fragment shader, that's by default using the texture in texture bank 0. And then we just have to bind our texture to it. So bind texture, this takes in type of texture, which is a 2D texture, and then it takes in the texture ID that we want to bind, which we can find in the texture model. That's texture model.getTexture.getTextureID. .getTextureID.
Ele mudou o nome? Não dá pra pular? Mentira. Pessoal do modo, refiz a primeira vez. Text ID. Ok, ele só mudou o nome. getTextID.
And there we go. Let's go ahead and run that, and hopefully, fingers crossed, that will work. There we go. So we've got the texture rendered nicely onto our quad. So that is it for this week. Next time we're going to be moving and rotating models using
cadê o resto?
matrices, and that video will be up next Saturday. You can check out my latest devlog video if you're interested. The link's on the screen at the moment, and links to my Twitter, IndieDB page, and my new Facebook page are in the description below. Hello everyone, and welcome to this week's lightweight Java game library 3D game tutorial. And this week aim it or shape wrong place. So let's actually be bind attributes and then GL link program. Secondly, if you go into the display manager class, to this bit of code program is linked, otherwise it doesn't work properly. So it should now be bind attributes and then GL link program. Secondly, if you go into the display manager class, to this bit of code from the very first tutorial, I found out that setting the context attributes has to be done all in one line like this. So it should be new context attributes dot with forward compatible dot with profile core. So now we can get on with some new stuff, and first off this week I want to talk about uniform variables. Before I explain what they are and why we use them, we need to remind ourselves of how the shaders are set up. So, as you all know by now, we have a vertex and a fragment shader. The inputs to the vertex shader come from attributes in a VAO, which the vertex shader uses to determine some per vertex outputs. These outputs are then when we load variables that can be two. So let's start off in location, take in code, and all we have to do here is call of the extract method, shorts for the. So now we need a few methods that can load classes, constructor. So now uniform location, the simple taking the load, and it's going to call the of the unit to load up uniform variable in the shader code. We can load up a vector location into it. Uniform of the x a boot. So now in shader, just going to of either 0 or 1 decide false code. And finally, the last type of matrix into the shader code into a mat location of that buffer to load up. We want to load up utils.c. That's going to be 6 before I'm going to put that location float buffer. Use these uniform variable in there. This is going to be a matrix, a uniform mat4, and we're going to call this variable transformation matrix.
Certo. E ele voltou com a cor. Transformation matrix. F4 F-color. Color F4 pos x mais 0.5 0 pos y mais 0.5 e 1.
I'll explain why later and what it's used for, but for now just know that it's a uniform called transformation matrix. So let's implement that get all uniform locations method, and in here we have to of course get the location of all the uniforms in our shader code, and we've only got one, and it was called transformation
Quem
matrix.
está desenvolvendo, aparecendo nos recomendados aqui, tentando fazer um tutorialzinho de OpenGL. Esse tutorial não é muito bom não, é de 12 anos atrás.
Location, an instance variable called location transformation matrix, which we will set to the location of that uniform variable. And now let's create a method that can load a matrix, load up a transformation matrix to that uniform variable. So we'll take in a matrix that we want to load up to the transformation matrix variable in the vertex shader code, and we already have a method to do this. We just have to call super.loadMatrix, takes in the location of that uniform variable and the matrix that we want to load up to it. So the first thing we're going to be using is, but what it is obviously and that we need to look traffic and some useful and the class for all of the useful little box. So, and I'll show you how we can do that in the code now. So we're going to create a new package called toolbox, and this is where all our useful classes to do useful little methods are going to go, and we're going to create a maths class for all the maths that we're going to be using in our game engine. And of course the first method that we're going to put in here is the method that we need this week, which is the create transformation matrix, and this is obviously going to return a 4x4 matrix, and it's going to take in the translation, which is a 3D vector. It's then going to take in the 3 rotation values, Rx, Ry, and Rz, and also the scale value. So let's just import them. Then the first thing we need to do is to create a new empty matrix, and very simple, new matrix for F. Then we need to set this matrix to the identity matrix, which, if you don't know what that means, it just basically resets
Ok. Ele tá fazendo isso aqui. Matrix 4 Matrix. Igual Matrix 4 Identity.
Sets the matrix. Then we're going to translate the matrix, and if you were worried that you didn't know enough matrix maths to do this, then it's your lucky day, because Lightweight Java Game Library has a load of stuff that does the matrix maths for us. So first we translated the matrix. By that translation, now we need to rotate the matrix around each of the three axes. So first,
Vou fazer uma funçãozinha aqui, vai. Private Matrix 4. Create transformation matrix. Vec3 translation. Float rx, float ry, float rz, scale. Aí, matrix 4 matrix igual a matrix 4 dentes. Matrix vezes igual matrix 4 translate.
first we'll rotate its rx, and we have to convert that to radians, around the x-axis, which we have to specify in this vector here. So a 1 in the x component and then a 0 in the other two, and we want to rotate the matrix and
Translate transactions matrix vezes igual matrix 4 rotate x rx.
we'll store it back in matrix.
Precisa matf radians rx.
And you'll have to cast that first argument to a float. Then we need to do this 2 more times.
Será que é de ponto cabeça aqui também? YZ YZ.
One for each axis. So we're then going to rotate our y around the y-axis, and finally our z degrees around the z-axis. So we've now translated and rotated our matrix, and finally all we need to do is to scale it. And first we need to specify the scale in all 3 axes, and we're just going to scale it uniformly over in all directions. So put scale in
vector 3 scale
times, and we want to scale our matrix and save it in matrix.
scale.
So now we have our transformation matrix, we just need to return it, and that is how you create a transformation matrix.
Turning matrix.
So next week what we're going to do is to introduce the idea of entities into our code, where each entity has a model and also a position, rotation and scale that define how and where that model should be rotation apply each by either model before an edit vertex has to come through the vertex shader once each time it's going to be rendered, and so we can transform them in here before they get rendered to the screen. And this is where uniform variables will be really useful, because we'll be able to load up the transformation matrix for each entity that we want to render from the Java code. So to render a forest of 100 trees that we want to render from the Java code, to load up the transformation matrix for each entity that we want to render from the Java code. So to render a forest of 100 trees, what we would need to do would be to render the tree via determine where matrix loaded up the transformation, because to dealing the works is basically a position is a vector which we made into a 4D vector. And a vector is basically a matrix as well. The transformation you'll be happy to hear that we're almost finished with the basics
Nossa,
now.
ele não usou pra nada.
Hello everyone and welcome to this week's light season, and then create a new in position rotation, and entities will allow us.
Ai, Deus. Enti. Aqui, class. Private texture model.
To have multiple entities that all use the same texture model,
Vector
which
3
means we'll be able to render a certain textured model many times in the world,
which
but we'll only have to
float.
load up the model once. So let's
Float
just go ahead and generate a constructor here by going.
Calma. Float y. Float z. Which float scale.
So let's just go ahead and generate a constructor here by going to source, generate constructor using field.
Wiki entity texture model v3 position float x float y float z float scale model submodel position recebe position float x yz scale
and just click OK. So now we have a constructor, and then we're just going to add a load of getter and setter methods, generate getters and setters, select all, and then click OK.
Nossa senhora. Public texture model get model return model public vector 3 get position return position public float get hot x return hot x y z public float get scale. Ai, tem os sets também. Puta que pariu. Return scale. Tem os sets também. Texture model. Set model. Texture model. T. Model recebe T. Public vector 3. Não, aqui é void. Set position. Vector 3 position. Model. Recebe model. Position, position. Aqui void set row x float x, recebe x, y, z, não, y, só que maiúsculo, z, e finalmente aqui, float scale,
Okay.
É isso mesmo.
And we're just going to add a couple of extra methods in here to move the entity around. So I'm going to add a method here called increase position that will be able to move the entity in the world.
Void increase position, float dx, float dy, float dz.
And this will take in an x, y, and z value of how far
Position x
and all that we have to do in
mais
here is
igual
to
dx,
increase the current entity position by
yz,
the x, y, and z values that we take in. And then I'm going to create another method that basically does the same, but for the rotation of the entity. So it will increase rotation, it will basically rotate the entity by a
O
certain
set scale tá setando root z. É mesmo. Valeu. Valeu, chat.
amount. Again, it'll take
Chapada de código, mano.
dz. Each of these represents
Eu refiz todo o tutorial aqui do OpenGL, eu só não consegui fazer esse Advanced Light aqui. Eu não consegui fazer, mas eu consegui carregar o modelo. Consegui fazer todo esse capítulo de Advanced de OpenGL. E o joguinho 2D que ele faz aqui, eu consegui fazer. Menos esse debug aqui. Esse debug aqui eu também preciso arrumar. Tá disponível no GitHub, quem quiser.
the degrees we want to rotate it around.
Certo. Public void. Increase rotation. Float. Qual é daqui? Aí root x mais igual a dx. YZ.
Each axis, and then again we're just going to increase current rotation by these values that we're taking into the method. So that's pretty much the entity class done. So now we can go ahead and update the renderer to update the render method. So
Ixi, a vida. Isso aí é em renderer.
that it now renders entities instead of just textured models. And let's also take in the shader here so that we can upload
Static shader, não sei se eu vou precisar. Intit.
the entity's transformation so that it renders the textured model in a different position. We're still going to need to access that textured model, so we'll take it out of the entity here.
Model.
Entity.getModel.
Aqui troca para home model.
And now we want want to load up the entity's transformation,
Entity get
position, rotation, and scale
model.
to the vertex
Aqui model. E aqui também model.
shader to that matrix, that transformation matrix uniform variable that we set up last week, and that will move the textured model. It will move where our model is rendered on the screen. So we need to create a transformation matrix.
Vamos ter que pegar daqui. Pega isso aqui. Vai lá para render. Colocar aqui. Aí aqui, Matrix 4. Transformation Matrix. Recebe Create Transformation Matrix.
Using that method in the maths class that we created last time. And that's going to take...
Nossa senhora. Entity get position.
In the entity's position, the entity's 3 rotation values. So entity...
Tá. Entity get rox. Entity get roty. Deixa eu só confirmar isso aqui. Acho que dá para confirmar aqui. Selected block. É. Ele ponto cabeça. Eu acho. Não sei. Vamos ver. RZ. Entity get root z.
Get rot x, get rot
E scale.
and
Entity get
entity
scale.
get rot z, and also the entity's scale, entity.get scale.
Nossa senhora, que bananagem que tá fazendo aqui. Voltei.
The entity's position, rotation, and scale, and now we can load up this transformation matrix to the shader using the method that we used last week, that we created last week in the shader class. So load transformation matrix, and that will take
Shader. Então a gente pega o shader daqui. Sei lá. Render. Deixar. Render. Pega o shader daqui. X. Public. Render. Aqui, shader. Shader tem que vir antes de tudo. Aqui shader. Mate 4. Aquele nome esquisito. Transformation matrix.
Take in the transformation matrix. Let's now go into the main game loop class and let's create an
Será que vai dar
entity so that we
certo?
can test all this out. So let's create an entity called entity, and this is going to take in the textured model that we want it to represent, which is going to be our textured quad, and then it needs to know the position that we want to render this entity at. And we're going to render it at -1x00. So that should move the quad one position to the left. And we're not going to rotate it, and the scale is just going to be...
Static model? Como assim static model? Ah! Tá, ele mudou o nome. Ok. Static model. Nossa, ele muda os nomes no meio do tutorial, velho. Static model new vector 3 -1 0 0 model position rotation 0 rotation 0 rotiz 0 scale 1.
We need to update what we're putting into the render method. We're going to now render the entity, and we also have to give the shader.
Poderíamos manter o shader lá. A gente pode fazer assim, shader. Aí a gente traz o shader de volta. E não precisa esse construtor aqui. Aqui, shader. Nossa, ainda escrevi errado. Shader.
Yeah, and that should work. And there you go. You can see that the textured quad.
Ah, ele trocou a cor.
Have to give this and we're not going to rotate it. Let's now go in.
Aqui. Trocou a cor. 0 3. Mas deu certo.
To the main
Vai,
game loop class, and let's create an entity so that we can test all this out. So
Uma vez que eu tentei fazer esse tutorial, não tinha dado muito certo não.
Take in the textured model that we want it to represent, which is going to be our textured quad, and then it needs to know the position that we want to render this entity at, and we're going to render it at, and to get x the textured quad has been moved over in the -x direction. We can also make use of those couple of methods that we put in the entity class. So if we increase the position of the entity in the positive x direction every frame by 0.002, And let's also rotate it so we can see that working. So every frame we're going to increase the position and increase the rotation.
Essa parte eu não sei se vai dar certo.
And that working. So
Increase position.
every frame we're going to increase the position and increase the rotation.
0.002 F 0 0 Shift increase rotation 0 1 0.
And if we run that, you should be able to see that working quite nicely.
Nossa senhora. Funcionou. Da última vez não funcionou.
So the X position of the entity is increasing, as is the rotation. Let's now try something else. If we put this back at 0, 0, 0, and now try increasing the Z position.
Zero. Zero.
By minus
Ele tirou isso aqui.
0.002. So this will move the
Menos 0,2.
quad backwards into the screen and run that. It doesn't.
Ah, tá.
Move the quad backwards into the screen and run that. It doesn't look like anything's happening. Let's have another look.
Ah, não acontece nada em Z. Z não acontece nada.
At the OpenGL coordinate system to understand why this happens. So we've got the x-axis going across the screen to the right, and we've got the vertical y-axis going up the screen. And finally, we have the z-axis, which it's impossible to draw here, but you have to imagine it pointing directly out of the screen towards you. So if we look at our quads, change screen further a model the distance, and also makes them for distance. So let's now go back into the code and set up the projection
Vamos lá. Deixa eu fechar tudo isso aqui.
matrix. So in
Program
the
também,
vertex
acho que pode
we
fechar.
need another uniform variable, which is also going to be a matrix, a map4 variable, and we'll call it
Projection matrix.
projection matrix. And to apply the projection matrix transformation, very simple, we just have to multiply it by the result of the transformation matrix multiplied by the input vertex position. So now we need to set up some stuff in the static shader class so that we can load values to that uniform variable. So like we did with the transformation matrix, we need to get the location of the uniform variable by calling getUniformLocation and putting in the name of the uniform variable, which was projection matrix, and we'll store the location in the variable location projection matrix. And then when we want to load a matrix up into that uniform, we'll have to call this method that we're creating now, the load projection matrix, which will take in the projection matrix that we want to load up, and then we can load it into the uniform by calling load matrix, which will take in the location and the matrix that we want to load up. So let's now go into the renderer class and actually set up the projection matrix itself. So let's declare a matrix 4f variable up here called projection matrix, and we need to have a few constants defined, such as the field of view angle that you want your projection matrix to have, to define the exact shape of the frustum that we want to create. So I've set the field of view to 70. I'm going to set the near plane variable to 0.1, and I'm going to set the far plane variable, which is basically how far you can see into the distance. I'm going to set that to 1000 for now. Then we need to actually create the projection matrix itself. So
Calma.
then we need to actually create the projection matrix itself. So let's create a private method down the bottom here that will initialize the projection matrix itself. And I've actually got the code for this copied because, as I said, it's not overly important, so I'm not going to explain.
Nossa. Load. Screen edit. Screen edit. View. Tangente. Match F. Radians. Pode dividido por 2 vezes expected. Meu Deus. Y scale dividido por expected plus length far plane menos near plane. Ok, a gente não vai usar nada disso. Projection Matrix 4 Perspective. Field of View. Radiance Fog. Expected. Screen Width. Float. Screen Height. Near plane distance. Near plane. Far plane distance. Far plane.
Why this is the code, or
Isso aqui
how
provavelmente a gente já
works.
paga.
But as I said, there are links in the description which will explain that sort of stuff to you. So just copy that down now, and we need to call this method at some point. So let's now create a constructor for the renderer class, so that the projection matrix is set up only once, because it only needs to be set up once. It's never going to change. We'll set it up right at the beginning when the renderer constructor is called, and we'll also take in the static shader because we want to load this projection matrix up straight away into the shader. It only ever needs to be loaded up once right at the beginning because it's never going to change. So we'll start the shader.
Shader use. Shader. Projection. Projection matrix.
Then we'll load up the projection matrix and then we can stop it again. And then we never have to load that projection matrix up to the shader again. It will stay there and it will work every time. Now in the main game loop, we need to change this a bit. We actually have to put that after. Creating the static shader now, so that we can put the static shader in as a parameter. And that should now work nicely. So let's go down here and we can test that out. And that should now work nicely. So let's go down here and we can test that out. Let's move the entity, let's render it initially at -1, and then let's move it back a bit faster. And let's try that, and there you can go. There you go, you can see it zooming off into the distance there and getting
Foi-se embora.
as it goes. Now, there is one final factor that changes where an object is rendered onto the screen, and that is the camera position. As you can see here, the camera is moving to the left, which is causing all of the rendered objects in the world to move right across the screen. Now, this is just a simple GL0 is to see the objects that if cameras move transfer isn't or once ever called camera, and that will just be a
Câmera.
vec3, and we'll initially set that to 0, 0, 0. Then the camera also needs a rotation around the X, Y, and Z axis, or this is also known as the camera's pitch, which is how high or low the camera is aimed. The camera's yaw, which is how much left or right the camera is aiming, and the camera's roll, which is how much it's tilted to one side. So if the roll was 180, the camera would be upside down. A quick constructor. Would be upside down. A quick constructor, don't really need that actually. And now let's have some getters. So select getters and click OK. And I don't know why they're all protected. Make sure that you've got yours as public. And I'm also going to add a move method here, which we can call whenever we want to move the camera around. So we'll probably call this every frame to move. And I'm also going to add a move method here, which we can call whenever we want to move the camera around. we'll probably call this every frame to move the camera every frame, and we're just going to check the keyboard inputs here so that we can move the camera with our keyboard. So I'm going to check if the key W is pressed, and if it is pressed, we're going to move the camera in the -Z direction. So we're going to change the Z position of the camera. We're going to make it 0.02 less. Then if the D key is pressed, we want to change the camera's X position. We want to increase it by 0.02. And finally, if the A key is pressed, we want to decrease the camera's X position to move it to the left. So now we want to create the view matrix from the camera's position and rotation. And to do this, we basically do the opposite of what we would usually do. Position and rotation. And to do this, we basically do the opposite of what we would usually do, because we want everything to move in the opposite direction. So I've got the code here actually just to
Ixi, a vida. Não entendi o que ele tá fazendo aí. O que geralmente se usa look at. Ué. Não dá? A baba? Yep. Acho que isso dá certo.
Speed up this tutorial. But all we're doing is we're creating a new matrix. We're then rotating it first instead of translating first, because it's the opposite way around everything. And then we want to make the position negative, because we obviously want to move the whole world in the opposite direction to the camera. And we're then translating the matrix and then returning it. So that will create the view matrix, which is the opposite of the camera's position and rotation. We'll then want to load it up to the shader program every time the camera's position changes. So we'll have a new uniform variable called view matrix, and we have to multiply it in like the others, but it has to go in between the projection matrix and transformation matrix. Then again, in the static shader, we have to do our usual setup. So create a variable to store the location of that uniform, and then we have to get the uniform's location, and the uniform is called view matrix. And then, of course, we need a method to load up the view matrix, which we will call load view matrix, and this is actually going to take in the camera, and we'll create the view matrix in this method. So it takes in the camera, then we'll create the view matrix from the camera. So matrix 4f view matrix equals, and then we'll use that method in the maths class, create view matrix, which isn't there. Just have to save it first. No. Oh, I didn't make it static. Don't forget to make it static. Yeah, so view matrix equals maths.create view matrix. That takes in the camera. So we've now got our view matrix, which is going to move the whole world in the opposite direction to the camera to simulate a camera, even though there is actually no camera. And then we'll load up that view matrix to the shader. So let's go into the game loop to test all this out. We need to create
Oi,
a
Amy.
camera that we can use.
Meu nome não é Amy, meu nome é Morgana.
We'll create a camera called camera and call the constructor. To test all this out, we need to create. So let's go into the game loop to test all this out. We need to create a camera that we can use. So we'll create a camera called camera and call the constructor. And just import that. There we go. And every frame we are going to want to load up the camera or the view matrix to the shader. So let's call shader.load view matrix. That will move the whole world to make it look like we're
Vixe vida.
moving the camera. And let's actually move the camera every single frame. So we'll call
Como é que eu vou fazer isso? Tenho que obter o câmera daqui. Vou ter que pegar daqui. Gambiarra! Acho que isso funciona.
camera.move, and that will take in the keyboard inputs. Let's try that out. And
Ué? Ah, tá. Entendi. Câmera? Aí. Tira essa linha aqui. Ok, funciona. Esse aqui não tá usando pra
you
nada.
can see that that's just about working. It's a bit hard to see because this cube, the square, is moving back so fast. So to make it easier to see, I've created a cube. I've written down all the vertices and indices and texture chords, and you can find all that data in a text file which I've linked in the description, so you don't have to copy all that down. So to make it easier to see, I've created a cube. I've written down all the vertices and indices and texture chords, and you can find all that data in a text file.
E eu tava mutado esse tempo todo. Beleza, agora os índices. 4, 5, 6. 4, 6, 7. 8, 9, 10. 8, 10, 11. 12, 13, 14. 12, 14, 15. 16, 17, 18. 16, 18, 19. 20, 21, 22. 20, 22, 23. Tudo certo.
which I've linked in the description so you don't have to copy all that down. So you can just copy and paste it. Let's now render the entity at -5z so we can see it a bit better.
5, remove essa linha.
Let's not move it backwards, but instead let's rotate it by calling entity dot.
Colocou em cima. Ok. Cheating crazy. Rotina? Escrevi errado. Rotation. Vocês nem vão usar.
Increase rotation and rotate it around the x and the y axis.
Vai. Please rotate. 0.
Axes. And then go ahead and run that, and there is
Funcionou.
cube, but it looks
O dele tá um pouquinho mais oco.
crazy, and that's because the triangles are just rendering on top of each other. We haven't
Por que é tão difícil? Como usar o Blender? Cara, não faço ideia. Blender não é para os fracos.
What we do need to do then is to tell OpenGL to test which triangles are in front of each other, and we can do that by enabling the depth test. So OpenGL will test which triangle is in front of which and then render them in the correct order. So GL depth test, and we need to clear the depth buffer every single frame.
Tinha alguém fazendo curso de Blender lá no server.
Putting that extra bit of code in there, and if we go ahead and run that, you can see a cube rendered nicely and rotating in 3D space. So that's it for this week. Next week you'll be able to load up your own models that you've exported from Blender or other 3D models.
Nossa, eu tenho que adaptar muito o código dele.
Hello everyone.
Esse aqui que eu não consegui.
And welcome to this extra
Essa
lightweight
parte.
Java game library 3D
Aí eu desisti do tutorial.
I wasn't intending to do an extra tutorial this week, but the tutorial was turning out to be a bit too long for one video, so I thought I'd break it down into 2 episodes. So today is just theory, no programming, and on Saturday we'll do the actual coding. This video is just going to introduce the OBJ file format, which we'll be programming our game to read in on Saturday. So if you're already familiar with the OBJ format, then you can just skip this video and do the one on Saturday instead. So in our game, to load up a model, we need these arrays of model data. One array for the vertex positions, one array for the texture coordinates of these vertices, and finally an array of indices that determine
Sim, load. Loader.
which vertices are connected to which. Now, currently we don't have any good way of creating these arrays of data, and we've had to hard code them into the code so far. Obviously this is very time consuming, and for more complex models than a cube, it would be pretty much impossible. What we want to be able to do is to create our models in a 3D modeling software and then somehow convert those models into the arrays of data that we need to load up the models in our game. So I'm using Blender here, which is a pretty cool 3D modeling program, and there are loads and loads of tutorials on YouTube where you can learn how to use it if you don't know already. It's free to download, and a download link for it is in the description of this video. And I've also put a download link for this model here in case you don't want to make a model yourself. So, once you've got a model, you need to export the model from Blender to save the model in a certain file format. And we're going to want to export the model to this wavefront.obj file format. Then before you export it, you need to make sure that include normals, include UVs, and triangulate faces are all selected, and then you can go ahead and save the OBJ file. Save it wherever you want, but make sure that you move it into the game's res folder, because that's where our game is going to try and read it from. So you'll now have an OBJ file like this one that contains all of your model's data. So you can open up your file in Notepad and see what it looks like. First, we've got a few random things here at the top, and then we've got a list of lines with the letter V in front of them. And these are a list of all the vertex positions in the model, so each one of these lines is a 3D coordinate of a vertex in the model. So that's good, that's pretty much exactly what we need, an array of the vertex positions. Then we've got a load of lines that start with BT, and this is a list of all the UV texture coordinates in our model. Again, that's exactly what we need, so that is pretty much...
Vamos ver. Está Blender. Vai como os models. Ok.
Perfect. Next we have a list of 3D coordinates in these lines beginning with VN. And these are actually the normal vectors at the vertices, which we don't need at the moment, but we will be using them next week, so they're also pretty important. So far it seems like this file format is basically perfect. It contains an array of the vertex positions, the texture coordinates, and the normal vectors which we'll be needing next week. It would seem that all we need now is the indices. Well, unfortunately, it's not quite that simple. Our game needs the arrays of data to all be in the same order. So the first vertex position uses the first texture coordinate and the first normal vector. And the 23rd vertex position in the list uses the 23rd texture coordinate and the 23rd normal vector. That way we can use our index buffer to say, for example, connect vertex 2 to vertex 4 to vertex 1, and it will automatically know the texture coordinate and normal vector for each vertex as well. Unfortunately, the lists of data in the OBJ file are ordered in a seemingly random way, so the first vertex position in the list might need to use the 6th texture coordinate in the list, or the 10th normal vector, or something like that. And that's what this next set of data in the OBJ file tells us. The F at the beginning of each line stands for phase,
Já volto.
so each line
Voltei.
represents a triangle in the model. A reference uses the 7th vertex position in the vertex position array, which has the 2nd texture coordinate and the 1st normal vector in position.
Aqui ele só tá falando do formato.
All model like this into our game. But yeah, thank you guys very much. Hello everyone and welcome
quero
to this
código.
Java game library mod obj file. It's going
Loader.
to load it up, get all the data, and then return it as a raw model that our game can render. We'll also take in the loader so that we can load up the data to a VAO once we've read it in. So first thing we need to do is to open up that obj file. So we can do that with a file reader. So let's create a new file reader, and this needs a new
File
file.
reader.
So we need to get the file that the obj file is in. That's going to be in the res folder, and it's always going to be .obj. So we can put those bits in already, and it just needs to know the actual name of the file. And we'll just catch an exception if that file isn't found, and then we'll print this error message to the screen, to the console. So now we can create a buffered reader to allow us to read from this file. So that's new buffered reader, and that's going to take in the file reader.
É.
Now,
Que o caldo azeda.
there's just a few things we have to set up. Set up a string called line. That's where we're going to read in each line of the.
Vamos voltar aqui.
Take in the.
Certo. Traduz esse trem aí pra mim. String path. Path combine. Ah, não. Isso aqui não precisa não. Faz assim. Has models. File name. .obj. Try-catch. De forma eficiente. For each string line. File read lines path. File not found reception. Debug error. Return no.
The file reader. Now let's give ourselves a bit of space here. There's just a few things we have to set up.
String line.
Set up a string called line. That's where we're going to read
List
each line of the file to.
vector
We
3
need a list of vertices which
vertices.
we're going to read in from the file, and that's a vector
No
3f
list.
because
Array
both
list.
these vertex positions are 3D coordinates. Then we need a
List
vector
vector
2f list,
True.
That's going to be the texture coordinates, all the texture coordinates in the file that we're going to read in.
New
Read
list.
them into this list. Then we need another 3D vector list for the normal vectors, which I mentioned in the last tutorial.
Normals.
We'll be using them for lighting next week. And then we need a list of integers, which is the indices.
List range. Indices.
So let's now create a float array,
Float.
because eventually we're going to need all the data
Vertices
in float
array.
arrays, because that's how our loader needs the data to be in order for it to load it up to a VAO.
Float
let's just
normals.
The vertices
Array.
array and the normals array and the texture array as well. And
Texture
we also need an int array
array.
for the indices array for the index buffer.
Int
So let's put this all in a big
indices
try loop, and we'll catch any
array.
exceptions that would come from an invalid file format. We'll just print the stack trace
Brackets.
console. So now we're going to have a
While.
infinite loop that's going to read
Re-
through the file until we want to break out of this loop. So
Line.
every time it's going to loop, it's going to read the next line. And we're then going to break that line into separate parts. We're going to split each line at a space.
Read. Shared.
And if you have a look at the OBJ file format, you should see what that would do. So we'll
Como é
then
que faz string
check
agora?
to see if the line begins with a V, which would mean
Volta. Reader. String reader. Ih, rapaz. Aqui não pode ser isso. L.
and you line with n, it's going to the stack int next line.
Ou por quê? String reader. Reader igual new string reader. Path. Reader. Reader line. String corrente. Line igual line split.
And if you have a look at the OBJ file format, you should see what that would do.
So
we'll then
line
check to see if the line begins with a V, which would mean it would be a vertex position.
V.
We'll also check if it doesn't begin with a V. We'll check if it
Let's
starts
see
with
if
VT, which would be a
line
texture coordinate. So we're just working out
VT.
what the data in the line that we've just read in is. We'll also check if
VN. Não. VN VT.
it's normals, or we'll check
E já volto.
if it is
Voltei. Oxe, ele trocou de novo. VT, VN e F.
face. So if the line that we've just read in is indeed a vertex position, then we need to create a new vertex. We're going to read in the data from that line and create a new vertex. And to read in the data, we just need to pass the float in the line that we've just read. So current line 1, because current line 0 would be the V.
Nossa senhora. De onde saiu esse? Ah, é 1. E de onde saiu esse 1? 2, 3.
And then current line 1, 2, and 3 will be the actual vertex data. So once we've got the vertex, we can add it to that list of vertices that we set up earlier. And we have to do basically exactly the same if the line is a normal vector. If the line is giving the data about a normal, then we need to read in the normal, just like we read in the vertex position, and then we'll add that to the list of normals. If it is in fact a texture coordinate in the line, then we have to read in the 2D vertex vector even, and we do that in basically the same way. Just pass the float in element 1 and 2 of the current line, because element 0 would be that VT. If you have a look at your obj file, you should see why that is, and then we'll add that vector, that 2D vector, the texture coordinate, to the textures list. Then if the line starts with an F, that means we've moved on to the next section of the obj file. We've read in all the data from the vertex, texture coordinate, and normals. So we've got all the data we need, and now we can break out of this loop. But first we're just going to set up the arrays now that we know the size of them. So the texture array is going to be the number of vertices multiplied by 2, because of course each texture has 2 floats. The normals array is going to be the number of vertices.
3. Nossa senhora.
Times 3.
Vai dar certo.
Each normal is a 3D vector, so has 3 floats. And then we're going to break out of that while loop. So we're then going to go into another while loop to loop through all those face lines, the lines beginning with F that give the information about each triangle. So while line is not equal to null, so while we haven't reached the end of the file, we'll first check, make sure that the line does start with an F, and if it doesn't, we'll just read the next line and then continue back to the beginning of this while loop. So once we've found a line that does begin with F, so it's a face, we're going to break the line up into 3 parts, one for each vertex. If you saw the last video, you'll understand that. So we split at the spaces, and that will give us a string array, the first part of which will be the F, and then the next 3 parts will be the 3 vertices of the triangle. So vertex 1 will be, of course, in current line 1, and we're going to split that. We're going to split that for each vertex at the slashes, which will now give us a string array of numbers. Now, we're going to create a quick private method down here because we need to do the same for each vertex, so we don't want to code this 3 times. So to process each vertex, we'll call this method, and this is going to take in the string array of vertex data, like vertex 1, vertex 2, or vertex 3 that we've just created. It's also going to take in the list of indices, the list of texture coordinates. We also need to take in the list of normals, and then we also need to take in the float array of textures, the float array of normals, and that is it. Oh, this should be vector 3f. So, for each
Ah, tá. Achei que eu ia ter que voltar.
of these vertices, this data for each vertex, which tells us which texture coordinate and which normal vector are associated with which vertex position, we want to put these into the correct position in texture and normals array. So the first bit of data will tell us the index of the vertex position in the vertex positions list. We'll have to minus 1 because the obj files start at 1, and of course our arrays start at 0. So we get the current vertex pointer, which is going to actually be the index for this vertex, so we can add that to the indices. And now we want to get the texture that
Isso foi café chá.
vertex.
Já falei, não bebo café, mon.
Texture index is in the second bit of the vertex data, so vertex data
Só
element.
penso em café.
That will give us the index. We have to minus 1 again of the texture in the texture list, so we get that.
E agora? Como é que isso aqui fica? Eu estou sedento. É porque acabou o café? Café ainda tá caro? Nunca bebi café. Tá. Texturas. Vertex data. Números 1. Funcionou não. Ah, tá. Também. Int parse vertex data 1 menos 1.
Texture, and then we're going to add it into the texture array, but this time we're going to put it in the same position as the vertex position, but we're of course going to have to multiply it by 2.
Int vertex pointer. Vertex pointer vezes 2. Int text.
Because
X.
texture coordinate has 2 floats, and we have to do this for the y position, the x position, and the y position
2 mais 1.
component of the texture
Y.
coordinate. Adding 1 for the second one. And we also
Quais são as chances disso dar certo?
1 minus the current one.
Ah, caraca, que coincidência. Eu tava escrevendo um parser para objeto um dia vai adicionar suporte para MTL também. Cara, eu não faço ideia do que tá acontecendo. Eu não sei inglês. Eu só tô seguindo esse tutorial aqui. Eu sei carregar objetos. Os objetos eu tenho. Tem esse projeto aqui no GitHub. Esse projeto aqui tá no GitHub. Deixa eu ver aqui. Esse aqui. Esse aqui é o mais legal de mostrar. Esse aqui é o mais legal de mostrar. Não faço ideia para que serve, mas é o mais legal de mostrar. 2000 anos para carregar. E isso. Ele explode. Que foda. Eu fiz isso aqui em live. O código está disponível no GitHub. Eu só não consegui fazer a luzes avançadas. Não consegui fazer esse capítulo aqui de Advanced Lighting. Depois a gente tenta.
Y position of the texture because OpenGL starts from the top left of a texture, whereas Blender seems to start from the bottom left.
Vertex 3, corrente norme.
Now we'll get the normal vector that is associated with this vertex, and the index for that is in vertex data element 2, and again we have to minus 1.
Não sei nem para que serve esse parse. 2 menos 1. É isso?
Which will be at the current vertex pointer multiplied by 3 because normals are 3D vectors.
Normals array.
For the x, y, and z component of the normal, adding 1 to
vezes
pointer
3 igual
each time.
normal x mais 1 mais 2 y z. Sei nem pra que serve esse parse. Não sei se eu tô fazendo certo. Eu não sei de nada, gente.
So we'll now call this method for each of the vertices in the triangle that we're currently processing. So process vertex once for vertex 1, and then let's copy and paste
normals,
that for vertex
texture array,
and vertex 3. So
normals array.
Processed the current triangle, and it will have sorted the normal and texture coordinates into their correct positions. And then, of course, each loop we have to read
the line.
So, once we've finished reading the whole...
Read. Close. O campo não pode ser anulável. Que campo, cara? Tanto a forma do objeto em si quanto o seu material. Esse objeto guarda instruções de objetos no espaço 3D. Salve! Desenvolvendo o QI, tentando carregar um objeto.
Whole file, we have to close the reader, and then at the end of all of this, we need to convert the vertex list into a vertex array, into a new float array. So, I'll do what's happened here. So we have to create a new float, and the size of this a new float array, and the size of this float array is going to be vertices dot size, because it's going to be the same size as the vertex list but multiplied by 3, because this time we're putting them in as floats, not vectors. And we also have to convert not again. We have to convert the indices list into an int array. So let's now copy across all the data. So we'll loop through the list of vertices, and for each vector in that list of vertices, we need to put them into the vertices array. We need to put each component of each vector into this float array, this vertex position array. So do that for the x, y, and z components, and that will do that for every vertex in the list.
Todos os bindings que vejo por aí são diferentes do que estão aqui. Porque fui inventar de nascer pobre. Agora eu preciso saber como recortar vértices.
And then we just have to copy across the indices.
Por que você precisa saber recortar vértices?
Into the indices array. So indices array element I is equal to indices.get I, and then we just have to return the loaded model, which we can load using the load method, and put in the vertices array, textures array, and indices array, and that will return a raw model that our game can.
Volta.
And that will.
A gente não definiu o texture array ainda.
Return a raw model that our game can now use. So let's go into the main game loop and let's do this. So we can delete all of these. Return a raw model that our game can now use. So let's go into the main game loop and let's do this. So we can delete all of these previous model data that we've used.
Tá, ele apaga tudo isso.
And the raw model we can now set to obj loaded.load obj model. Put in the name of your obj file. So for me that is stool, and we'll put in the loader as well. And I need to change the texture that I'm using.
Loader. Onde está loader aqui? Loader. Ok, aqui é. Já que tá loader, loader. Stall. Loader.
Which is stool. Make sure you've got the correct textures.
Esse aqui joga pra cá. It's not that.
And model files in your res folder. I'm going to move it back to -50Z, and I'm going to just rotate it around the y-axis.
0.
So we can actually have a good look at it. And run that. And there you go.
Não vai dar certo. Não vai dar certo. Opa! Ih, mano, tá desenvolvendo o que em Java? Em Java, nada. Em C Sharp, o que ele tá fazendo em Java? Ai, carambola. Abracadabra, carapato, carambola. Ai, daqui 1000 anos o Gemini responde. Daqui 1000 anos vou me lembrar. Aí aqui. Pra colar. Puxa. Certo. Vamos ver se ele arruma. Tá. Ele tirou isso aqui. Certo. Aí tem o try. Vem. Spring. Reader. O new string reader. Path. String line. Caralho, que susto. Já entendi. Ok. Aí aqui. Corrente line. String split options. Remove entries. Se corrente line ponto length igual a 0. Continue. Corrente line é 0 igual a V. C. Corrente line é 0 igual a VT. Corrente line é 0 igual a VN. Corrente line é 0 igual a F. String. Ele tirou isso aqui. String Vertex 1, vertex 2, vertex 3. Process vertex. Break. While. With line not igual a null. Corrente line. Split. String options. Remove impite entries. Continue. What? Olha só, passo primeiro. Debug log error. Text pointer. For each. Array impite float. Não deveria estar vazio, mas... Vamos ver. Não funciona. Tira essa porcaria aqui temporariamente. O código dele não funciona. Pelo menos não pra mim. Se eu pôr espacinho aqui. Não funcionou. Tem que ler esse arquivo aqui. Tem que ler esse arquivo. Nossa, tem quantas linhas esse arquivo? 1600. O Gemini não coisa.
Este arquivo é um formato OBJ, Wavefrom OBJ, que é um formato padrão para representar geometria 3D. Ele foi exportado pelo Blender V2.67. Aqui está o que cada parte do conteúdo significa. Vertex são as coordenadas dos pontos no espaço 3D x, y, z. Por exemplo, V3.2271240.0651271.0000000 define um ponto específico.
Tá. Blá, blá, blá. Não estou vendo nada na minha janela. Parece que estamos em frequências diferentes. Você comentou blá 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 sobre a minha análise técnica do arquivo anterior que mencionou. Não sabendo nada de janela. Se você estiver se sentindo entediado ou apenas querendo conversar sobre algo mais real ou poético do que geometria 3D, estou aqui. O que está acontecendo aí fora? É uma vista bonita ou de sincero? Não vejo o VJ sendo renderizado na janela do meu OpenGL. Às vezes eu desabafo com o Gemini por ligação. Ligação? Existe isso? Ah, entendi! Você achou que eu tô falando o quê? Da janela de casa?
Ah, entendi. Agora a imagem da janela com fundo verde explicou perfeitamente a janela que você mencionou antes.
É!
Quando a tela fica apenas com a cor de limpeza, esse verde, e o modelo 3D não aparece, geralmente é um destes motivos clássicos no OpenGL. Principais causas e soluções. A câmera matriz de visualização, view projection. O objeto pode estar fora do campo de visão da câmera, atrás dela.
Né? O... Atrás do campo de visão da câmera? Pera aí. Acho que não, mas não custa tentar. Não, não tá não. Não, o problema está no arquivo obj loader. Tem um modo meio que de ligação. Meu Deus, mano. Meu Deus. Entra em cal, abre o microfone. Abre o microfone, entra em cal, a gente conversa. Pode colar? Esse aqui, querido. É o que você acabou de fazer. Fez errado, faz de novo, faz direito. Não dá pra seguir com esse tutorial. Já basta conversar. Já basta conversar no trabalho. Ué. Você tá conversando com a IA, se eu tivesse a oportunidade, eu nem abria mais a boca. Mas, então por que você tá conversando com a IA? Nossa, velho, essas IA estão ficando ignorantes, né? Break. Interrompe a primeira face. Então tá, vou tirar isso aqui. Remove break. Não funciona. Ai, meu Deus do céu. Não dá pra seguir com esse tutorial. Ela não reclama do quanto sou ignorante. Por isso que a IA tá ficando ignorante. Ah, velho, não funciona. Texture array. Boa no. Não funciona. Continue, bababá. Nossa senhora. Ontem eu fui pra uma seresta. Aqui, que é isso? É de comer? Não vai funcionar. Opa! Eu não consigo ir pra frente? Ou eu vou muito lento pra frente? Teve algum resultado. Eu vou muito lento pra frente.
It has worked.
É, mas a textura cagada. Já sei. Vamos de texture. Aqui. Save image. Set. Flip 1. Funcionou. Hoje eu não quero sair de casa. Todos os dias quando acordo, não tenho mais o tempo que passou, mas temos todo o tempo.
Now set
Temos todo o
we think that we
tempo
have set
do
up
mundo.
model data that we've used, and the raw model we can
Todos
now
os
set to
dias.
objloader.load obj model, put in the name of your obj file. So for me that is stool.
Caraca, deu certo. Agora isso aqui. Assim? Assim, assim? Foi. Deu certo, viado. Será que dá certo com o outro? Vamos testar. Como sempre, que essa vez dá certo com o que eu quero. Miniscript. Miniscript mods immersive assets immersive models block metal multiblock arquifornice. Eu ainda quero que arquifornice funcione. Textures blocks não, models arquifornice. Eu ainda sonho com um dia que a arquifornice vai funcionar. Arquifornice. 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 Porra nenhuma. Ué? Onde chama essa linha? Ah, sério? Por que arquivar nisso não funciona? Arquifornice. Qual a diferença de vocês dois? Nenhuma. Isso aqui. Comento. Não, cacetada. Ah, saco. Né, Arquifornice. Ninguém quer renderizar Arquifornice. Só a Unity renderiza Arquifornice.
And we'll put in the loader as well. And I need to change the texture that I'm using, which is still make sure you've got the correct textures and model files in your res folder. I'm going to move it back to -50Z, and I'm going to just rotate it around the y-axis so we can actually have a good look at it. And run that, and there you go, it has worked thankfully perfectly, and that you can just about move the camera around to get a better look. Unfortunately we didn't add an up option to our camera, so we can't go up, but you can see that it's working there, and that is all that we need really. So hopefully that will work for you too. If you didn't understand what we just did, then please have a look back in the previous tutorial, which will explain the structure and layout of an OBJ file in much greater depth, and then have a look back through the code, and hopefully you'll be able to understand what we've been doing in this video. So that is it for this week. Next week we're going to be adding lighting into our game, which will be lovely, and that... Hello everyone, and welcome to this week's lightweight Java game library 3
Ai, meu Deus.
tutorial. And this week we're going to be adding lighting into our game. So I've been messing around with the code.
Você vai dar esse modelo aí pra baixar? Dragon Model. Salvar como? Tipo. Tipo. Ok.
From last week's tutorial and trying out a few different models, and here you can see that I'm code from last week's tutorial.
Ok. Dragon. Texture white? Vamos ver que porcaria acontece.
Tutorial and trying out a few different models, and here you can see that I'm rendering the Stanford Dragon model, which you can download for free from many sites. I'll put a link in the description for it. But as you can see, it doesn't look
Sorry que por isso não carrega.
just using a completely white texture here, so all you can see is basically a silhouette of the dragon, because the texture is all one color, and we haven't yet implemented lighting. So that's what we're going to do today, and the first thing we're going to
Sim.
do is to add a class to represent a light in
Nossa, que preguiça de fazer esse tutorial. Ver light. Okay, class light.
entities package. So this class is going to be pretty simple. All it needs really is a position, so a vector 3f, a 3D coordinate for the position, and also a vector 3f for the color, which is also going to be like the light intensity. Then we're just going to go to source and generate constructor using fields, select all and click OK. So we've got a constructor there. And then we're also just going to set up some quick getter and setter methods. So select all again and click OK. And that's all we need.
Nossa senhora. Position, position. Color, color. Eu fiz get set. Tá. Position. Return. Position. Void set. Position. Retrieve position. Position, position. Vector 3 get color. Return color. Okay, void set color. Vector 3 color. Color, color.
In the light class. The lighting calculations are all going to be carried out in the shader programs, so we need to have access to the position and color of the light in our shader. So in the vertex shader, we're going to set up a vec3 called light position, which is going to obviously
Uniform vec3 light position.
hold the position of the light. And then in the fragment shader, we are going to need another vec3, and this is going to be the light color.
3. Aqui e light color. E caiu a live?
So now we need
Voltou.
to do the usual things with the uniform variables. So in the static shader class, we need two more ints, which are going to hold the location of the light position uniform variable and the light color uniform variable, just as we did for all the matrices. And as usual, we have to
Puta
get
que
the location
pariu.
of the uniforms in the get all uniform locations method. So we do that once for the variable which was called light position, which was in the vertex shader, and we'll do the same again, saving this in location light color. We're going to save the location of the variable that was called light color. And now we need a method to load up these light variables. So we're going to create a method called load light. It's going to take in a light, and then we're going to make use of the load vector method in the shader program class to load up the light position to location light position, and then we want to load up
O código dele é muito
color
ruim, velho.
to location light color, and that will load up the values to the shaders. So now we have the light position and color in the shader, but we also need something else to allow us to calculate how bright a given point on an object should be. If you have a look around you in your
De
room,
12 anos
wherever you
atrás
are,
também.
I'm sure that there'll be some light coming from somewhere, and some objects around you will presumably be being lit up by this light. And if you look at these objects, you will of course see that the sides of the object that are facing the light are more lit up than parts of the object that are facing away from the light. So the more that a surface faces the light, the brighter it appears. So in order to do our lighting calculation, we're going to need some indication of which direction parts of the model are facing. And this is where normal vectors come into play. A normal vector is a direction vector that points in the exact direction that a surface faces. Every point of a surface has a normal vector, and it's always pointing directly out of the face, or in other words, it's perpendicular to the face. Basically, the normal of a surface tells us which direction it's facing in, and that is exactly what we need. And luckily for us, the OBJ files provide us with the normal vector at each vertex of our model, and we loaded all of these normals into a float array last week. So, if we want to be able to access these normals in the shaded code, we need to put them into the model's VAO, along with the vertex positions and the texture coordinates. If you remember from before, in our model's VAOs, we currently store vertex positions in attribute 0 and texture coordinates in attribute 1. So we might as well go ahead and store the normals in attribute 2. So let's now go and do that in the code. So go to the loader class, and in the load to VAO method where we load the data up to the VAO, we now want to load up the float array of normals as well. So let's take in
Normals.
another float array called normals, and now we can make use of the store data in attribute.
2, 3. Normals.
List method. We want to store the data in attribute 2. Each normal is a 3D vector, so 3 floats, and then we just put in the float array of normals, and that will store it into attribute 2 of the VAO. Now in the OBJ loader class, we want to call that method and put the normals in there, and I think they're called normals array.
Isso. Aqui. Normals array.
Array. So put in the normals array so that they get loaded up into the VAO. But of course, we need to access these normals in the vertex shader, and to do that, we have to bind the attribute of the VAO to a certain variable in the vertex shader. So let's bind attribute list 2, which was the normals, to a variable called normal in the vertex shader. And of course, we have to actually go into the vertex shader and create that normal variable, which is an in variable because it comes from the VAO data. It's a vec3, of course, because normals are 3D vectors, and it's called normal. One last thing that we have to remember to do in the renderer class, just before we render stuff in the render method, we need to enable that attribute in the VAO. So gl enable
Render. Enable 2. Disable 2.
enable vertex attribute array 2, and then after we've finished rendering, we need to disable it again. So gl disable vertex attribute array 2. So in the shader, we now have the normal at each vertex and the position of the light source. So we are now able to calculate how bright each point on the object should be. To do this, for a given point on the object, we're first going to find the vector from that point on the object to the light source.
Blah, blah, blah.
This object's vector here is to the light. How called this concept is that or not, then it might be a product of two perpendiculars. Some vectors aren't on. Let's first get rid of all this color stuff because that is from tutorial
Isso aqui tem mais.
2 or something. And now let's set up the two output vectors of the vertex shader, and that's going to be these two vectors that I've been talking about, the surface normal and the vector pointing towards the light source. Both
Acho melhor dar o mesmo nome que ele tá dando aí pra esses negócios. Position. Texture. Coordinates. Pass. Texture. Coordinates. E aqui, normal.
vec3s and both out variables.
Alt vec3 surface normal. Alt vec3 to light vector.
Because we're sending them to the fragment shader where we will use them in the final calculation. So you might think that the surface normal should just be equal to the normal that we get in, but let's not forget that sometimes we're going to rotate our model. When we have the transformation matrix, it's going to rotate our entity. So the normal also has to be rotated as well, because the normal is going to change its direction if the entity is rotated. So we have to do transformation matrix multiplied by the normal, and we have to make the normal into a 4D vector so that it can be multiplied by the 4x4 matrix, which is the transformation matrix. And that's going to return a 4D vector, so we now have to swizzle it, I believe it's called, and get the XYZ component of that resulting 4D vector, and we'll save the X, Y, and Z into surface normal. So with the two light vector, we need to get the difference between the light position and the position of the vertex on the model. So you might think that that would be just light position minus position. Position is the position of the current vertex. But of course the position will change if we have used a transformation on the position. So we first have to multiply the position by the transformation matrix. And we don't want to do this twice, so let's do it at the top here once to get the world position of the vertex. So after it's been transformed, rotated and translated to wherever it is in the world, and then we can finally get the light position minus the world position of the vertex. And the world position is a 4D vector and we just need it to be 3D, so just get the X, Y and Z components of it. Then in the fragment shader, let's get rid of that color thing.
Aqui, on the texture.
And
or color.
In the so just get the X, Y and Z components of it. Then in the fragment shader, let's get rid of that color thing, and we're going to take in those two normals.
Aqui eles chamam de or color.
That we outputted from the vertex shader, the two vec3s, 3D vectors, the surface normal and the two light vector. Make sure you spell them the same, otherwise it won't work. And now we're going to do the final calculation, which is that dot product. But first we have to normalize these two vectors to make sure that the size of the vectors is 1, so that the size of the vectors doesn't affect.
Isso pra cá, meu Deus do céu.
the result of the dot product. So
It
we normalize
normal.
function here to normalize first the surface normal
Normalizing.
and the
Surface normal.
light vector normal. If you don't know what normalize is really doing, then it would be a good idea to read up about normalizing vectors, but it just makes the size of the vector equal to 1. The direction of the vector stays exactly the same, so that only the direction matters and the size of the vector is irrelevant. Now we're going to do that dot product calculation, and there's a function to do that in GLSL, just dot, and we put in the two normals that we want to dot together, and we get the result, which is a float, which will be representative of how bright this pixel should be. We now need to make sure that this result lies only between 0 and 1, because sometimes the dot product will return values of less than 0, and we don't really care about them. We're just going to want to make them 0, so we use this max function, which takes either n.1 or 0, depending on which one's higher. So if n.1 is less than 0, the float brightness will be set to 0, but if n.1 is higher than 0, then it will be just set to n.1. We're then going to multiply this brightness factor by the light color to get the final lighting color, the final light value of this pixel, and we're going to multiply that, the light, by the texture color, and we have to make it into a 4D vector first, because texture is a 4D vector. So now
Tá certo isso?
vector first, because texture is a 4D vector. So now, final thing we have to do in the main game loop, we have to create a light. We need a light source to light up our model. First we have to put in the position of the light source, and that is going to be, I'm going to put it at -20, because I put my model at -25 and I know that this is going to look awesome. And we have to set the color, and I'm just going to set the color to white, so that's 111 in the RGB values there. And the last thing we have to do is load up the light to the shader every frame. You could do it just once at the beginning, but we'll do it every frame, and then you could change the position or the color, and it would be updated in the shaders. So
Calma. Shader. Shader light. Shader light. Light position. Então é um VEC 3. Light position.
for the variable which was called light position, which was in the bird's light color, and now we need a method
Também tem light color.
to load up. It's going to method in the to location light position light color, and that will load up the values to the shaders.
Load vector.
So now we have the light position and color in the
Tá. Light get position. Light get color. Acho que
to put in the position of the light source, and that is going to be, I'm going to put it at -20 because I put my model at -25 and I know that this is going to look awesome. And we have to set the color, and I'm just going to set the color to white, so that's 111 in the RGB values there.
dele é uma confusão.
And the last thing we have to do is load up the light to the shader every frame. You could do it just once at the beginning, but we'll do it every frame, and then you could change the position or the color, and it would be updated in the shaders. So let's run that. And there you go.
Vamos ver. Deu errado. Linha 21. Aqui. Não tá igual dele, não. E ele mudou a cor aqui, ele nem avisa. Sai mudando tudo.
Frame, and then you could change the position.
Cinco, assim.
And that is going to be, I'm going to put it at -20 because I put my model at -25.
Tem uma iluminação e não é igual dele.
And there you go, look at that. The light is working perfectly. It's all looking pretty good. And yeah, a pretty nice outcome. So that is it for this week. Next week we'll be adding
Ficou bom não.
lighting to make objects look all shiny, so that will be lovely. Don't forget to follow me on Twitter and Facebook, and it would really help me out if you could maybe like this video if you found it useful. Also, a link to yesterday's devlog video is on the screen now, and this week I was demonstrating the Entity Editor tool.
Specular Light, otimização,
Thank you guys very much for watching this
Simple
video.
Terrain.
Subscribe if you haven't already.
Mano, eu vou continuar isso amanhã. Cansei. O código dele. Eu tenho que fazer muita interpretação, velho. O código dele é horrível. Nossa, tem muita coisa pra fazer. E o código dele é muito ruim. Muito ruim. Então é isso, meus gralhas. Esse foi a live de hoje. Obrigado a todos que assistiram. Vocês são um público maravilhoso. Um beijo, tia Morgana. Solta a franga da live.